Hello everyone, I welcome you to this learning activity. In this learning activity, we are going to classify image pixels. So we've worked through multispectral imagery, so where we have more than 3 spectral bands, and we've worked through Landsat and Sentinel-2. And normally you have multiple bands, and you're going to use these bands and then allow the computer to classify the pixels or cluster the pixels. So this is a typical example of a satellite imagery of 6 spectral bands. And then the computer is going to use these spectral bands and take every pixel in the image and then cluster the pixel into a theme or classify the pixels. So you're going to produce something like this where those pixels that are green are seen as one theme and those in blue one theme, and so on and so forth. So this is what you're going to do in this section, all right? So there are 2 methods of classifying image pixels. So you are either doing it by unsupervised method where essentially you ask the computer to look at the distribution in the pixels and the relationship between each other. Then create clusters. So you're going to have a cluster of pixels, and then you, the analyst, will finally come in and then label these clusters, okay? Alternatively, you can rely on yourself where you're going to give the computer a bunch of training data, and then the computer is going to use this data to label all the pixels in the image, and this is what we call supervised classification approach. So in this particular session, we're going to focus on unsupervised. So what this means is that the computer is going to do the majority of the work, and by looking at the relationship between the pixels, for example, the distance between each pixel and the others or the neighbors, and then also the computer is going to look at the spectral properties, and then based on that is going to create a bunch of clusters. Normally the number of clusters is defined by you, the analyst. So you tell the computer, oh, I need 5 or 7 or maybe 10 clusters from this image, and then the computer is going to produce that. But another role you are going to play is that once the computer has created these clusters of pixels, you come in and based on maybe additional data or background knowledge of the study area, you are going to give labels to the clusters for them to become meaningful to the user. So one of the widely used clustering algorithm is the k-means clustering, and this is what you're going to use in this session. So for example, what you see here is a 2D feature space, and where you go x-axis to be band 3, and in this case, let's say band 3 is red light, and then band 4 is near infrared light. So this is a distribution of the data points. You got 20 data points. But when you give this information to the computer, it's going to use these 2 bands and then look at the distance between each point and the neighboring samples, and then based on that, the computer is going to partition this into clusters. And like I said, the number of clusters is always specified by you, the analyst. So let's say you say, oh, you want let's say 7 clusters. The computer is going to produce something like this. And in this case, this is the output where the computer is saying, well, there's one cluster where you need sample ID 12, 20, 11, 15, 16, and 13 to be one cohort or one cluster. And then where you go pixel 9, 14, and 18, another cluster. And then pixel 10 and 19, another cluster. And so this is how the clusters are created by the computer. And then you finally come in, for example, you look at this big cluster here, and then based on additional information or your expertise. So this actually is a golf course. And then you look at this one here and say, oh, that is water. And so these labels, these themes, are given by you, the analyst, okay? So what we're going to do in Earth Engine in a sec is that you're going to be given a multispectral image and this is going to be a Sentinel-2 image. And then you are going to leverage the spectral bands and then ask the computer through k-means algorithm to create clusters for you. So you're going to specify the number of clusters you want. And so you're going to have output which may be similar to what you are seeing here. So you're going to have, the clusters that are yellow, clusters that are green, the clusters that have been identified as blue. And this is all meaningless, but you have to now come in later to say, okay, maybe the yellow clusters you see there is maybe, let's say, pasture land, and so on and so forth. So we're going to do this in Earth Engine. So let's head over to Earth Engine.